So let us list the 7 base quantities and their units and 2 supplementary quantities and their units in SI, the international system I mentioned little time back. So I am just constructing a table. So you just follow it. First of all, I write the physical quantity. The first one, the name of the physical quantity. Okay. Second column, headline, is the name of the unit. And the third column, the symbol of the unit. Of course, I shall discuss this in detail after some time, but this is just the beginning, okay? Symbol of unit. And we are going to list the name of the 7 base quantities and their units first. So first start with the base quantities. These are, first of all, length. Length is a base quantity. Its unit's name is meter. So I said earlier that the MKS system that came before the international system is the predecessor or forerunner. So you can see here the unit of length is meter. That was also for the MKS system earlier than that. And the abbreviation, the symbol for meter is M, just M, okay? This is M. Next comes mass. Mass is a base quantity. Its unit is kilogram. Again, a reminder of MKS. In that unit, that system also, the unit of mass was kilogram. And the unit is kg. I'll explain later that kg is made up of 2 parts actually. The gram is standing for G, that is G is standing for gram, and K is a prefix that is standing for kilo. To be explained more detail in a short time, okay? Next one is time. Time you have seen so far in all the systems. It has got the same unit called second. So here again the unit is second, and the symbol is small letter s. Next we come to thermodynamic temperature. This is not just temperature. See the term, they are using thermodynamic temperature. Let me write it taking some space. Thermodynamic temperature. This is also called absolute temperature or Kelvin temperature. This is the modern unit of temperature, not the CGS. CGS was Celsius earlier, and then FPS was Fahrenheit. But today in SI, the unit is Kelvin temperature, named after Lord Kelvin. And this temperature being the base quantity, its unit is called Kelvin. This is small k, although named after a scientist. You write the full name of the unit, use small letter, that is Kelvin. But while writing the symbol of that, it will be capital K. I shall explain these things point by point, but you are already seeing a few things and trying to keep them in mind. I said unlike the first 3 things, meter, kilogram and second, the unit of temperature is Kelvin, named after a scientist. So while the full name contains a small letter, unlike the scientist's name, but the symbol contains capital letter in respect of that scientist. Next comes electric current. Electric current is the 5th member in my list of 7 base quantities in SI. Electric current. The unit is ampere, again named after a Frenchman, a French scientist. The full name contains small letter a, but while writing the symbol, we must insist on the capital letter A here. Then, a term that might defy you at this stage because you have not learnt about optics in details, but this is called luminous intensity, something to do with optics, the science of light. Luminous intensity. As I already said, this term might defy you, but we shall just come to this in due course. The unit of luminous intensity is called candela. This is candela. And in symbols, this is called small c followed by small d, CD. That is the symbol of candela, the unit of luminous intensity. And finally, the seventh base quantity is called amount of substance. This is amount of substance. The unit is called mole. And the symbol is just get rid of the E thing at the end and you call it simply mole. So you see not much difference between the full name MOLE and the symbol that is MOL. Okay? Okay. Now these are the seven base quantities. The last one, you might wonder that if mass tells me the quantity amount of matter in a substance in a body, then what is amount of substance? Now this unit that is mole and this quantity that is chosen because by Avogadro's theory you were aware that hypothesis 1 mole is said to be and a number of 6.022 into 10 to the power 23 entities, which may be atoms, molecules, ions, anything, and that particular quantity and the unit mole appear to be very helpful, very convenient, in spite of the fact that amount of matter has got a different unit of mass that is of course much more familiar. Now these are the seven quantities, seven base quantities, and we have said there are two supplementary base quantities also in SI. So I have decided to defer the introduction of supplementary units to the next page after some time. But let's look at the seven base quantities and their units in the SI, International System. Once again, let's have a look. These base quantities are length, corresponding unit is meter, then its mass, kilogram was the unit, then time, unit is second. These three we have already heard about. Length, mass and time, the units have been used to name the previous units like CGS, FPS, MKS and so on. We have four more base quantities. One is thermodynamic temperature, that's also called Kelvin temperature, named after Lord Kelvin, the Scotsman, who introduced this system, this particular unit of temperature. Then electric current, this is of course the amount of charge passing through any cross section of a conductor per second. This is also a base quantity, unit being ampere. Luminous intensity, a part of optics, but I can tell you this much. This is the amount of light energy crossing per second unit area. That is a measure of luminous intensity. Once again, it's the amount of light energy passing through a unit area in unit time. Now the unit of that is candela. And finally, we said amount of substance, although it sounds something similar to the mass quantity of matter in a body, but the corresponding unit mole is a tremendously convenient unit in physical studies. So we have got seven base quantities here, and we shall learn their formal definitions, the way they have been chosen, because you remember that I told you that this is not a simple process. When all over the world, the whole science community wants to make use of the same unit for a particular quantity, the choice of the unit has to be very clearly defined, very rigorous and invariable, so that everywhere somebody can create 1 meter as the base reference, say in length, in mass, kilogram, second, Kelvin, whatever. The meaning and the definition of these units must be universal, is clearly defined so that it can be emulated at any part by the scientific community. So you must understand the definitions have to be very rigorous, which we shall give now. So once again, I'll look at those at the table and the corresponding quantities and their units before we go for the definitions in a very short time.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.